All right, the next thing we look at in the graphs of the trigonometric functions is called phase shift. Back in college algebra, you did see taking graphs and shifting them horizontally to the right or to the left. In trig, we don't call that horizontal shifting. We call it a phase shift. Excuse me. So what I've written down here is, in general, if you see a function, or y equals, it's of the form a sine quantity bx minus c, or it could be written as a sine, like square bracket b, parenthesis x minus c over b, or if the trig function happened to be cosine. It doesn't matter how it's written, this form, or if it's cosine, that form or that form. We already know the amplitude is going to be absolute value of a, whatever that number is. And we know the period is going to be 2 pi over b, whatever that number is, 2 pi over whatever the b happens to be. So here's what, let's try to discover a little bit about where this phase shift comes from. It doesn't matter either one of these equations, or either one of these equations, it doesn't matter what the form is. We know one complete cycle. Let's see, we know one complete cycle on the basic graph of sine and the basic graph of cosine. One complete cycle takes place from 0 to 2 pi. So I'm going to use that as my motivation here. And I'm going to say one complete cycle happens from this junk here, going from 0 to 2 pi. And again, the basic graph of sine and the basic graph of cosine makes one complete cycle from 0 to 2 pi. So it's just kind of like I'm taking this stuff that's in the parentheses and setting it equal to 0, taking it and setting it equal to 2 pi. Again, it doesn't matter if it's sine or cosine function that I'm talking about here, and it doesn't matter which of these two forms I'm talking about. Well, let's just play around. Let's see if we can solve this equation for x. Well, I think we'd add c to both sides, and then divide both sides by b. Well, look at that. We were able to solve it for x pretty easily. Can we solve this equation here for x? Sure. Add c to both sides. Divide both sides by b. What is it we have done here? Good question. This here. This would be the left endpoint of one period for the graph of this function, this form or this form. That would be the left endpoint, whatever c divided by b is. This here is the right endpoint of one period, the graph of one period. Looks like this, this, or this, or this. That's the right endpoint of one complete period, of one cycle. So I do have to point out this c over b, it actually has a name. This number c over b, that value, whatever that number is, that's what's called the phase shift. That is the number that gives the phase shift of the graph. Okay, that's all well and good. More importantly, it's the process that we go through. So you have an option. You can memorize formulas here, and I think they're going to be in your book as well. Or it's the process that I went through to show you what phase shift happens to be. The process of, to determine the left endpoint of one period, we take the junk that's in parentheses, set it equal to 0. Solve for x, we have the left endpoint of one period. To find the right endpoint of one period, take the junk that's inside parentheses, set it equal to 2 pi. Solve for x. That gives us the right endpoint of 1 period. And once we know the left endpoint and the right endpoint, we then find the midpoint, first quarter point, and third quarter point. And it becomes a very friendly process. I have to point out one more thing. Notice that the right endpoint, notice that is nothing more than C over B, that's the left endpoint, plus 2 pi over b. 2 pi over b is the period. Intuitively, that should make sense. The right endpoint of 1 period should be the left endpoint plus whatever the period is. Let's put this all together and let's try to do an example. All right, here we are, folks. We're going to sketch the graph of y equals 3 cosine 2x minus pi over 3. We're going to sketch that graph over 1 period. And here's the process I would go through, just in general. Probably the first thing I would find is the amplitude. Well, we know the amplitude is the absolute value of that number. So the amplitude is 3. Next, just find the period. We know the period is 2 pi over b. Since b has a value of 2, the period is pi. So I know the period has a length of pi. Next, the next thing I do is I find the left endpoint of 1 period. So let me abbreviate left endpoint of 1 period as LEP. That's the left endpoint of 1 period. Here's how I find the left endpoint of 1 period. It's just like in that derivation I just showed you. I take the junk that's inside parentheses. 2x minus pi over 3. Set it equal to 0. Solve for x. So I add pi over 3 to both sides. Divide both sides by 2. That's the left endpoint of 1 period. Once I have the left endpoint of 1 period, I get the right endpoint of 1 period. Now there are 2 ways you can get the right endpoint of 1 period. The first way, take the junk that's in the parentheses, set it equal to 2 pi. Now solve for x. So add pi over 3 to both sides. See, 2 pi is 6 pi over 3. 6 pi over 3 plus pi over 3 is 7 pi over 3. Divide by 2. That gives me 7 pi over 6. So that's the right endpoint of 1 period. The second way to determine the right endpoint of 1 period is you take the left endpoint and add to it 1 period. And I kind of use that as a check. Notice pi over 6 plus pi. Pi over 6 plus pi, that's pi over 6 plus 6 pi over 6, which is 7 pi over 6. Hey, that's what I have here. So it checks. So once I know the amplitude, the period, the left endpoint and right endpoint, the next thing I do is start to make my coordinate system so I can sketch a graph. I immediately lay off 1 period on my x-axis. So the left endpoint of 1 period is pi over 6. The right endpoint of 1 period is 7 pi over 6. I gotta get a little more room here. Amplitude is 3, so let me get some scaling on my y-axis. Okay, now once I have my 1 period laid off on the x-axis, I go through the process of finding the 5 key points, the 5 quarter points. I have left endpoint, I have right endpoint. Next, I get the midpoint. And it's the same process that we've looked at already. Midpoint. It's halfway between pi over 6 and 7 pi over 6. How do I find the halfway point? Well, I add those together and take half of that. So pi over 6 plus 7 pi over 6 is 8 pi over 6. half of 8 pi over 6 is 4 pi over 6. Notice 4 pi over 6 would reduce to 2 pi over 3. Get the first quarter point. How do I get the first quarter point? I add those two together and take half of it. So pi over 6 plus 4 pi over 6 is 5 pi over 6. Half of 5 pi over 6, that's 5 pi over 12. Finally, the third quarter point. How do you get that? Well, you add those two together, divide by 2. So 2 pi over 3 plus 7 pi over 6. Remember, 2 pi over 3 is also 4 pi over 6. Add those together gives me 11 pi over 6. Half of 11 pi over 6 is 11 pi over 12. Now all that's left is plotting some points. And you know I'm going to put up here on the board one more time the unit circle. So here we go. We would put to find 5 points to plot, we would start off putting the left end point, pi over 6, back in here for x. Let's go through that. If pi over 6 comes in here for x, 2 times pi over 6, well, that's pi over 3. Pi over 3 minus pi over 3 is 0. Cosine of 0, it's dropping me off at that point there. Cosine of 0 is 1. 3 times 1 is, 3 times 1 is 3. So I can plot that point right there. When pi over 6 comes in for x, 3 comes out for y. When I put 5 pi over 12 in here for x, I better find myself ending up at this point on the unit circle. In other words, I better be a quarter of the way around the unit circle. When 5 pi over 12 comes in here for x, I better end up with all this junk here being pi over 2. So when 5 pi over 12 comes in here for x, 5 pi over 12 times 2, that's 10 pi over 12. That's 5 pi over 6. 5 pi over 6 minus pi over 3. Well, that's 5 pi over 6 minus pi over 3 is 2 pi over 6. So 5 pi over 6 minus 2 pi over 6 is 3 pi over 6, which reduces to pi over 2. It's exactly what it should be because that's the first quarter point. And then the cosine of pi over 2, it's that x-coordinate, which is 0. Continuing, when 2 pi over 3 comes in here for x, you multiply it by 2, gives you 4 pi over 3. 4 pi over 3 minus pi over 3 is 3 pi over 3, or pi. Cosine of pi is negative 1. So I got 3 times negative 1, which is negative 3. I put 11 pi over 2, or 11 pi over 12 in here for x. And I bet I end up right back here. And just kind of finishing it off quickly and connecting these 5 key points with a smooth curve gives me that as the graph of 3 cosine 2x minus pi over 3 over 1 interval. So that's the basic graph that's the graph of 3 cosine 2x minus pi over 3 over 1 interval. So to recap the process, see this mess. Just determine what the amplitude is and the period. Once you know the period, get the left end point of one period. Left end point of one period is found by taking the junk in parentheses, setting it equal to 0, and solving for x. And that gave us pi over 6 here. Get the right end point of one period, taking the junk inside parentheses and setting it equal to 2 pi, solving for x. Or you could have taken the left end point and added 1 period to it. Either way gives you the right end point. Lay 1 period off on the x-axis. So pi over 6 left end point, 7 pi over 6 right end point. find the midpoint, first quarter point, third quarter point. And then plot those 5 key points and connect with a smooth curve. That's how you would do a graph when you have a phase shift. The final thing that I'll talk about is when you have a vertical shift. When you have a vertical shift, that's when there's going to be a plus or a minus something in here. So for example, I just have enough room here. If we saw y equals 2 plus 3 cosine 2x minus pi over 3. Folks, you do the vertical shift the absolute last thing you do. And here's why. If I'm asked to graph this function, here's what I'm going to do. I'm going to find the amplitude. I'm going to find the period. I'm going to find the left endpoint of one period, the right endpoint of one period, midpoint, first quarter point, third quarter point. Basically what I'm going to do is I'm going to start off by graphing the 3 cosine 2x minus pi over 3. Then I'll take that graph, it's the graph I have here, and I'll apply this vertical shift to it. Since that's a positive 2, the graph of this beastie is nothing more than the graph that we have here for 3 cosine 2x minus pi over 3, taking this graph and shifting it up 2 units. And that's a very easy graph to do. Let me try to do it with some blue chalk here. Because once you have your 5 key points listed, it's nothing more than taking those 5 key points and just shifting the 5 key points, just moving them up 2 units. So this would come up here to a y value of 5. This would come up to a y value of 2. This would come up to a y value of negative 1, y value of 2, y value of 5. So if you just shift the 5 key points, that gives you the graph. So do the vertical shift last. Pretend it's not there. I would get that graph. I'm just going to graph that first. Then do my vertical shift, add 2. Shift it up 2 units. That's pretty much it. These are the more exciting ones. You get some vertical, or you get some amplitude in there, some period change in there, and some phase shifting in there. But it's the process that's pretty straightforward, and I encourage you to follow the process. Makes it a piece of cake. And that's it. Thanks for watching.